Hello, this is ICP-5 and in this ICP we have two parts. One is eliminating the overlayers in the dataset and other part is uh, finding the null count of the features and also finding the R squared and RMSE value. So first I will explain you how to eliminate the overlayers. Overlayers in datasets are the values that are measured mistakenly are the values that are entered mistakenly. So these values are not much of use for us. So when we try to predict an value, like when a model tries to predict an value, these overlayers will confuse the model and also gives a major deviation in the value that we are going to predict. So removing the overlayers is the recommended thing, but sometimes overlayers also helps us to find if there is any error in the model that we are doing. So first in this task our main aim is to delete the overlayers in the garage area dataset. So first, I have got the train.csv file. I am just reading this file into this train variable. And first, I need these packages. So I'm importing the pandas, numpy, and the matplotlib pyplot to plot the graph. So after that, I'm going to plot the scatter plot of sale price and garage area. By doing this, so I can find the values which are the overlayers. And after that, I'm going to filter the data which does not include the overlayer. So I'm going to take these limits as my lower and upper limits and I'm going to filter the data. After that I'm going to print the data. I will run this code and I will show you how this will print. So this is the data I got before removing the overlayer. So these values are can be called as the overlayers. This grouped data here is the useful data that we can use to predict the outcomes, but these values which are above the upper limit and below the lower limit, those data are called overlayers, which are not much helpful to us. And also after removing overlayers, my code will print the values like this, like all the values that you are seeing here in here. These are the garage area and the values that you are seeing below are the sale price. So this is the first task, and the next task is to do the multiple linear regression, and also find the R squared and RMSE values, like the values which will tell us how our dependent variables are deviating from the independent variables. So up first I have imported all the packages that are required for me. After that I'm reading the CSV file that I'm going to use into the train variable, and after that I'm describing it, which will print the particular values in the dataset. After that I'm going to select the data types that are included in the CSV file, and I'm going to store them in the AND features, like which is called as the numeric features. And after that I'm going to print the top three correlated features. For that I have to select the value over here 3. So how many you want, you can select the value over here and it will print those values up to that particular value. After that I'm going to count the null values in each and every feature, and later that I'm going to see if the sum of these features have any null value or not. So after that I'm going to consider the log value of the quality dataset in the CSV file, and also I'm going to store the dataset by dropping the quality column and storing it in the X. From this I'm going to train test split the entire dataset, which will be used to separate the training data and testing data. Later that I'm going to calculate the R squared and RMSE values. So here R squared and RMSE values will help you how the independent variables data is changing or deviating from the independent variables, and one will tell you how the change in the dependent variables is changing or deviating while you change the independent variables. That is what I'm calculating. I will run this and I will show it to you. You can see I'm printing the first correlation features, numeric features over here. After that, I'm counting the null count in each and every feature. Finally, I'm printing the r squared value and RMSE, root mean square value of this data set. So this is our two tasks for this ICP. Thank you.